Hello and welcome back. In this video, I am going to talk about trigonometric integrals. In my previous video, I talked about trigonometric substitution. So these are pretty similar, but there are some other things that y'all need to know. Trig identities are a key part in order to cope with different types of integrals, especially, solely those that involved trigonometric functions. So maybe the best known one is sine squared of theta plus cosine squared of theta, which equals 1. And then of course you can rearrange this as you please. It's important, though, to take into consideration that you can also express, like, for example, sine squared of theta as 1 minus cosine of 2 theta and everything over 2. Likewise, you can express cosine squared of theta on a similar way like sine squared of theta, except that if you want to express cosine squared of theta, you need to change the sign to a positive sign. Okay? Yes. So these are like half-angle identities. There are some others that are called double-angle identities. Like, for example, what would you do if you find something like this, sine of 2 theta? Well, you can express this as 2 sine theta cosine theta. Likewise, if you want to express cosine of 2 theta, it is simply cosine squared of theta minus sine squared of theta. So this is like these are the very basics. Now we are going to try to apply some of this into problems of integration. So let's get started. So the first problem will look maybe easy to you, but I just want y'all to start thinking like outside of the box, like tangent of x dx. So tangent of x is not any derivative of any other function, so that's a good indicator that you will have to do something else. So as you may recall, you can rewrite tangent of x as sine of x over cosine of x. Sine of x over cosine of x dx. And then from that point on, this is like a particular case, but you can do a simple use substitution. So you can assign u the value of cosine of x and then du to be minus sine of x dx. And now what you get to do is simply do the substitution to put all your knowledge in practice. So you just simply put minus du, since we've got a negative sign right there, and then down at the bottom you just get to put u, since we did all the entire process. So you can pull the minus sign off the integral, then stick to the rest of the things. Now you are gonna have to find the integral of 1 over u, which is fairly simple since it's minus ln absolute value of u plus c. However, before jumping into the final answer, don't forget to get back to your original variable, which is, you can recall, it was the entire cosine of x, and then we just close it as follows, plus c, since it's an indefinite integral, and you are all set. That was pretty easy, wasn't it? Now I am going to go over a more, I would say, challenging problem, more demanding maybe. So it's sine to the fifth of x dx. So if you happen to find something like this, and especially if it's an odd power, what you get to do is to split this off so that we've got sine to the fourth of x times sine of x dx. And now I know this looks like strange because sine to the fourth, what the heck is that the derivative of? But don't panic, since you can simply keep the 2 right here, make a big parenthesis, pull the 2 off, and keep the sine of x on the right hand side, and then of course dx. So what you got to do from this point is, based on the trigonometric identity, we get to express the sine squared of x as 1 minus cosine squared of x, everything raised to the second power, and then sine of x dx. From this point, the interesting part starts. So you get to do your u substitution. There are many u substitutions for these problems, so you get to get used to it. So our u is going to be the cosine of x, and our du will be minus sine of x dx. And then what we got to do, as you may know already, is just simply plugging in. So 1 minus, and then we put our u here, and it's squared, and then everything is squared, and then we put our minus du right there. Now we got to operate within the parentheses, so it's 1 squared, which of course is just 1, minus 2 u squared plus u to the fourth. And then we close parentheses, and then we've got a minus sign right there, which is actually multiplying the entire expression. So you got to be careful there, not to take it as if it were a subtraction or anything like that. So now what you get to do is simply, maybe we can pull this off and write this down so that it's more understandable. Now what we get to do is just simply to integrate every single thing. So our 1 is going to become into u, our 2u squared is going to become into plus 2u raised to the third power over 3, and then our u to the fourth, as you may imagine, well, is u to the fifth over 5 and then we just need to get back to the original variable. So at that point, you are almost set. However, it's important to stick to the variables and just keep moving forward. So, as cosine cubed of x, everything over 3, and then of course our cosine to the 5th of x over 5. And although there isn't enough space, but don't forget that we need to put our plus c at the end of our answer. So now I am going to jump straight into the last problem that we will be covering in this video. So this is more challenging in the sense that you really need to visualize the problem. So it's secant cubed of x dx. So here maybe you know that it's trigonometric, that it's a trigonometric integral, but you got to be careful because you will see something. So let's say that you decide to split this off like as we did last time, and then express it as secant of x dx. And then maybe what you want to do is to express that secant squared of x as 1 plus tangent squared of x, and then everything multiplied by secant of x, and of course dx. So let's say that you want to do u substitution, and let's say that you assign u to be tangent of x, and then du to be secant squared of x dx. Well, as you can tell at this stage of the problem, what we've got here is simply secant of x. So there is a long way from this to secant of x. So instead of scratching your head thinking into how to do the substitution, what I would tell you is to, okay, it's good if you decided to split this off. However, the fact that this looks more like a derivative and that this other expression that is on the right hand side looks more like an integral, maybe it's a great indicator that you get to do and that you get to apply another method of integration. So we can rewrite this just simply so that you can see everything, like the whole picture, and then you can do integration by parts. So don't forget that you need a u, a du, you will need a v, a dv, depending on what you've got here within the integral. So since secant squared of x is already a derivative, what you get to do is to assign dv to be secant squared of x dx. And then for v, you need to assign b to be tangent of x. Why? Because that's the integral of dv. And then for u, you can be secant of x. Very well. And then the derivative of this expression will be secant of x times tangent of x. And then you are good to start with the integration by parts. So just as a reminder, don't forget that the integration by parts works as follows. U dv, the integral of u dv, which is what we are trying to find, equals uv minus the integral of b du. So now it's just a matter of plugging in once again. So we've got our secant of x, and then for our v will be tangent of x, and then for our v du, again, our v is tangent of x times our du is secant, I will put it right here, secant of x, tangent of x dx. Alrighty then. So we've got another integral that we need to treat independently, because this is not going to change our procedure so much until we figure this integral out. So I am going to pull it off. So it's tangent squared of x times secant of x dx. Alright, so once again, tangent squared of x times secant of x dx. So now I am going to express our tangent squared of x as secant squared of x minus 1 times secant of x dx. Now what we got to do at this point is simply to multiply everything out. So that gives us secant cubed of x minus secant of x dx. Alright, so now we've got two terms that we can once again, sorry if I am being redundant, but we can once again split it off. Don't forget that this is just a part of the entire problem, so we need to add the expression that we are neglecting, which is secant of x tangent of x. So what we get to do, okay, so we've got to find the integral of secant cubed of x dx, and we've got to find the integral of secant of x dx. So now for secant cubed, once again we are going to take it as an independent integral. We can use a reduction formula. So if that's the case, we just simply use secant n minus 2, which is 1, so it's secant of x times tangent of x and everything over n minus 1, so the power minus 1, which is 2. And then we've got on the right hand side n minus 2 again, which is 1 over n minus 1, which is 2, and then the integral of secant of x dx. So now we'll have to cope with a really chunk of many things, but as long as you keep track of everything, you will be just fine. So 2, and then since we've got here, so the integral of secant of x is ln absolute value of secant of x plus tangent of x and everything. Don't forget about the denominator over 2. Now we can do, of course, the same thing for the other term, which is minus secant of x. So we will take our minus secant of x independently, which is ln Once again, just as a reminder, secant of x plus tangent of x, then absolute value once again. Now we can simply just add everything and put the final answer. So the first part that I told you not to forget is our secant of x, times tangent of x, and now what we've just found, which is plus, hold on, I think that, oh no, we've got a negative sign right there. So we simply copy everything as is. So secant of x times tangent of x minus, and then we start putting everything. So secant x, I will put it on the bottom, secant x times tangent x over 2, and then our minus ln secant of x plus tangent of x. Of course, we close this, and then 2, and then there is negative right here, so it's minus ln. So I will put it. Okay, so continuing with everything, minus ln secant of x plus tangent of x, and then plus c. So this is the answer. Secant x tangent x minus secant of x times tangent of x over 2 minus natural logarithm of absolute value of secant of x plus tangent of x, everything over 2, minus ln absolute value of secant of x plus tangent of x plus c, since it's an indefinite integral. And I will never get tired of emphasizing that, because it's really important. Thank you so much.